Hello students, last class, we learned about the fuel control system. This class, we will start to learn about the lubricating oil system of aircraft engines. The movement of human joints is inseparable from synovial fluid, and the operation of aircraft engines is also inseparable from the lubricating oil system, which is the lifeline for maintaining the mechanical integrity and reliability of the engine. Its functions can be summarized as follows. First, lubrication. A layer of oil film with a certain thickness is covered on the surface of the moving parts, so that the metal does not contact directly with the metal, but contacts with the oil film, thereby reducing the friction during the mutual movement. Second, cooling. Lubricating oil absorbs heat from the bearing and surrounding high-temperature components and transfers the heat to fuel or air at the radiator, thus achieving the purpose of cooling. Third, cleaning. When the lubricating oil flows through the bearings or other parts, it takes away the worn metal particles and separates these metal particles from the lubricating oil in the lubricating oil filter to achieve the purpose of cleaning. Fourth, anti-corrosion. The surface of metal parts is covered with a layer of oil film of a certain thickness, which isolates the metal from the air and prevents the metal from direct contact with the air, thereby preventing oxidation and corrosion. In addition, the lubricating oil system also provides working medium and seals for other systems, and is a carrier of the engine status. In turboprop engines, since the lubricating oil carries away a lot of heat, it can also serve as a heat source for the anti-icing system. Since the rotor of the gas turbine engine works at a high speed, the lubricating oil system is its important life support system. The reliability of the engine operation depends to a large extent on the operation of the lubricating oil system. Therefore, the lubricating oil system should meet the following requirements. First, when the engine is operating within the aircraft flight envelope, the lubricating oil system should ensure the supply of lubricating oil required by the engine. In particular, the system should have good altitude performance and can also ensure lubrication when the engine is operating at the ceiling. Second, the system lubricating oil consumption should be small. Third, when the engine is working, especially when the aircraft is flying at high speed, the hot lubricating oil after working should be reliably cooled under the condition of minimum power consumption to keep the lubricating oil working within a given temperature range. Fourth, under low temperature conditions, the system should be able to start quickly and reliably. Fifth, the location of the system should be designed to facilitate access, adjustment, maintenance, and inspection, and to allow for early detection of fault signs. Sixth, the accessories should be simple in structure, reliable in operation, compact in size, light in weight, and long in service life. This is a typical lubricating oil system structure diagram. From the figure, we can see that the lubricating oil system is mainly composed of a lubricating oil tank, a boost pump, an oil filter, a safety valve, an oil return pump, an oil radiator, an oil gas separator, an indication system, and a magnetic plug. Most gas turbine engines now have dry sump lubricating oil systems with independent external oil tanks. The structure is shown in the figure. The lubricating oil tank is used to store lubricating oil. It is usually welded from aluminum alloy sheets or steel sheets and is usually installed on the engine. Most lubricating oil pumps are gear pumps, as shown in the figure. Lubricating oil pumps are divided into booster pumps and return oil pumps. The booster pump and return oil pump are integrated, and their function is to increase the pressure of lubricating oil, while the return oil pump is to pump back the lubricating oil. The function of the oil filter is to filter the debris particles in the oil so that the oil supplied to the bearing is clean. The main oil filter, shown in the figure, consists of a housing, a filter element, a bypass valve, a one-way valve, and a pressure difference switch. The function of the oil or fuel radiator is to cool the oil and heat the fuel. In addition to using the fuel to cool the oil, the ram air can also be used to cool the oil. Therefore, the oil radiator is divided into two types: air or oil radiator and oil or fuel radiator. As shown in the figure, the oil or fuel radiator consists of a shell, a honeycomb, tube, a bypass valve, an oil temperature sensor, and other components. The oil-gas separator can remove bubbles and steam in the return oil, prevent oil supply interruption or damage to the oil film, and reduce lubricating oil consumption. Before the oil cavity gas flows out of the machine, a centrifugal ventilator can be used to separate the oil droplets in the air to reduce lubricating oil consumption. This is the basic structure diagram of a centrifugal ventilator. The working principle and structure of the oil-gas separator and the centrifugal ventilator are basically similar. However, due to their different functions, the centrifugal ventilator has a higher speed, and the oil-gas separator is an oil return circuit accessory, while the centrifugal ventilator is a ventilation system accessory. The oil system shown in the figure also includes an oil indicating system, which includes an oil temperature indicator, an oil pressure indicator, and an oil consumption indicator, a pressure differential switch, and a warning light. This is the structure diagram of the magnetic metal chip detector, which is usually installed in the oil tank accessory gearbox and the oil return pipeline of each bearing to detect the working condition of the engine parts and judge the wear of the bearings and gears. The above are the main components of the lubricating oil system. According to the nature of the circulation, the lubricating oil system can be divided into a pressure regulating system and a full flow system. In the pressure regulating oil system, the oil pressure in the oil supply circuit is limited to a given design value, thereby controlling the oil flow supplied to the bearing cavity. The oil pressure is controlled by the pressure regulating valve. When it exceeds the design value, it allows the oil to return from the boost pump outlet. It provides a constant oil supply pressure at all normal engine operating speeds. The full flow lubricating oil system does not have a pressure regulating valve, so its oil supply pressure increases with the speed so that the lubricating oil flow rate can meet the use requirements within the entire engine speed range. The lubricating oil pressure is determined by the boost pump, speed lubricating oil, nozzle size, and bearing cavity pressure. The lubricating oil system can also be divided into a single circuit system and a dual circuit system. The main difference between the single circuit system and the dual circuit system is whether there is an auxiliary booster pump in front of the booster pump in the circulation system. In the single circuit system, there is no auxiliary booster pump in front of the booster pump. The single circuit circulation lubricating oil system can be divided into two types: single circuit forward circulation type and single circuit reverse circulation type, according to the different positions of the lubricating oil radiator in the circulation system. As shown in the figure, the single loop forward circulation lubricating oil system installs the lubricating oil radiator on the oil return line. At this time, the lubricating oil temperature in the oil tank is lower, which is called a cold oil tank. The single loop reverse circulation lubricating oil system installs the heat exchanger on the oil supply line, as shown in the figure. At this time, the lubricating oil temperature in the oil tank is higher, which is called a hot oil tank. Its characteristics are all the lubricating oil used for lubrication and cooling returns to the lubricating oil tank. The radiator is installed on the oil supply line. There is less gas in the lubricating oil, which is convenient for heat transfer. The size of the radiator is small, and the oil supply pressure is maintained at a constant value by the pressure regulating valve. The system has good working performance and high altitude performance. This is the lubricating oil system of the WP7 engine, which is a single circuit pressure regulated forward circulation lubricating oil system. When the engine is working, the lubricating oil in the oil tank is pressurized by the oil inlet pump and filtered by the lubricating oil filter, and then sent to the bearings of the engine rotor and the accessory transmission casing, respectively. The lubricating oil of each bearing is collected in the front, middle, and rear 3 oil collection tanks after working, and the lubricating oil of each oil collection tank and the accessory casing is pumped back by their own return oil pumps. First, the large amount of gas foam in the return oil is separated by the oil-gas separator, and then cooled by the lubricating oil radiator, and finally enters the lubricating oil tank through the oil filling port of the lubricating oil tank. The gas, separated by the oil-gas separator, is discharged into the accessory transmission casing, and the gas in each oil chamber and the upper part of the lubricating oil tank is sent to the accessory transmission casing through the ventilation pipe. These gases must pass through the centrifugal ventilator before being discharged outside the engine. Students, in this class, we learned about the engine lubricating oil system. Understanding the classification of the lubricating oil system is a difficult point. I hope that students will review it in time after class and digest and absorb it. Thank you.